Hello there. Today we'll be treating a practice question for the 2026 WAEC Chemistry Practical. Let's get started. The question says, A is a solution of tetraoxosulfate 6 acid, while B is a solution containing 1 gram of sodium hydroxide per 250 cm3. It says, put A in a burette and titrate with 25 cm3 portion of a solution B using phenolphthalein indicator. Tabulate your readings and calculate the average volume of A used. Next, from your results and information provided, calculate the concentration of B in mole per dm cube. Also calculate the concentration of A in mole per dm cube. And finally, calculate the number of hydrogen ions in 1 dm cube of A. Also, the ratio is 1:2. That is, 1 mole of the acid is reacting with 2 moles of the sodium hydroxide. But before we calculate the concentration of B in mole per dm cube, we need to know the concentration of B in gram per dm cube. Remember that in the question we are told that B is a solution containing 1 gram of sodium hydroxide in 250 cm3. That is not mass concentration. A mass concentration is the amount in grams that is dissolved in 1000 cm3. But mass concentration equal to 1 gram is dissolved in 250 cm3. How many grams should be there in 1000 cm3? X grams becomes 1 times 1000 all over 250, and that will give us 4 grams per dm cube. But that is not the final answer. Then concentration in mole per dm cube is equal to concentration in gram per dm cube all over molar mass. But molar mass of NaOH is equal to 23 plus 16 plus 1 will give us 40 grams per mole. Always make sure you put your unit, correct unit. Concentration in mole per dm cube equal to 4 all over 40, which will give us 0.1 mole per dm cube. Then for the second question, we have concentration of A in mole per dm cube. Since we know the molar concentration of our B, we can now use the formula CAVA all over CB VB is equal to NA all over NB. Next, let's write out our variables. We have our CA is what we are looking for. CB is equal to 0.1 mole per dm cube. Then our VA is equal to 12.10. Note that this value is just the theoretical value for our VB is 25 cm cube. Our NA is equal to the number of moles of acid, which is 1, and NB is the number of moles of base, which is 2. Substituting, we have CA times 12.10 equal to 0.1 times 25. Okay, making CA the subject formula, we have CA is equal to 0.1 times 25 times 1 all over 12.10 times 2. The final answer should be 0.103 mole per dm cube. That is a molar concentration of the acid. To calculate the number of moles of hydrogen ion in 1 dm cube of A, we start with ionizing H2SO4. If 1 mole of H2SO4 is giving us 2 moles of hydrogen ion, that means 0.103 should give us X. Then X becomes 0.103 times 2 all over 1. That will give us 0.206 moles of hydrogen ion. Next, but we know that 1 mole of a substance always contain 6.02 times 10 raised to the power 23 particles. Then 0.206 should contain how many particles? Then we have X becomes 0.206 times 6.02 times 10 raised to the power 23. And that will give us a final answer as 1.24 times 10 raised to the power 23 ions, hydrogen ions. Bye for now.